Introduction to Statistics, Chapter 2, Section 2.3. Frequency polygon. A frequency polygon is a graph that uses points connected by line segments to represent the frequencies for the classes. A frequency polygon is constructed by plotting a point above each class midpoint on a horizontal axis at a height equal to the frequency of the class. Line segments are drawn connecting consecutive points. Two additional line segments are drawn connecting each end of the graph with the horizontal axis. A class midpoint is the sum of consecutive lower class limits divided by 2. Now let's look at constructing a frequency polygon. Given the following frequency distribution, construct a frequency polygon. There are 1, 2, 3, 4, 5 classes, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 50, along with their frequencies. So first, we need to find the midpoint of each class. So I'll insert a column for class midpoint. The midpoint of the first class would be 10 plus 20, the next class lower limit, divided by 2, which is 15. Next one would be 20 plus 30 divided by 2, etc. And when you get down to the last class, you're going to say, what am I going to add 50 to? Well, you take 50 plus the class width to get 60. So it's 50 plus 60 divided by 2. Another feature, if you look at it closely, the class midpoints. The difference between the class midpoints is the class width. In this case, the class width is 10, so the midpoints are 10 apart. Second, draw and label a graph. So we have a vertical axis, horizontal axis. On the horizontal axis, we put the class midpoints. On the vertical axis, we put frequency. And now, above each midpoint, we put its frequency with a dot. Fourth, we connect the dots with line segments. Fifth, we connect the endpoints to the graph. So the first one comes down, it's 5. The class width is 10, remember, so 15 minus 10 is 5. The other end, 55 plus 10 is 65. Gets connected at 65. But the frequency polygon must connect to the horizontal graph. And if you look at this, there are only 1, 2, 3, 4, 5 classes. So you should be able to look at a frequency polygon and determine the number of classes by looking at the dots. StatCrunch will draw a frequency polygon, but at this point, all you really need for the quiz is a conceptual understanding of a frequency polygon. You will need to examine different frequency polygons, see which frequency polygon goes with the given frequency distribution. You will be given a frequency polygon and asked to answer a few questions, such as, what is the class width, number of classes, frequency of a given class. Now let's talk about cumulative frequency distribution. A cumulative frequency distribution displays the aggregate frequency of the category. In other words, for discrete data, it displays the total number of observations less than or equal to the category. For continuous data, it displays the total number of observations less than or equal to the upper class limit of the class. So here's the example again, same example we were using. This time, I need to add a column for cumulative frequency. So I want to add the frequencies as I go through the table. So the first cumulative would be 4. For the second class, it's going to be 4 plus 7, 11. For the third class, it's going to be the 4 plus 7 plus 3, 14. For the next class, it's going to be 4 plus 7 plus 3 plus 5. And the last class, you add them all up, and you get 23. Cumulative relative frequency distribution. A cumulative relative frequency distribution displays the proportion or percentage of observations less than or equal to the category for discrete data and the proportion or percentage of observations less than or equal to the upper class limit of the class for continuous data. Using the same example, first I'm going to need to calculate relative frequency. So I put a column for relative frequency. Recall, relative frequency is frequency divided by sum of frequencies. So we're going to have 4 divided by 23, 7 divided by 23, 3 divided by 23, 5 divided by 23, 4 divided by 23. So those would be the relative frequencies. Now we want to do a column for cumulative relative frequency. Now we just go down, keep adding. So the first one is 0.174, then it's 0.174 plus 0.304. Now you can just add the relative frequency of the third class with our cumulative at this point. So we can just add 0.130, add 0.217, and finally add 0.174. We should end up with 1 or very, very close to 1 due to rounding. So in this case, I was rounding to 3 decimal places. So your cumulative should have been anywhere from 0.999 to 1.001. You're allowed a plus or minus 0.001 due to rounding on this one. Drawing an ogive. An ogive is a line graph that represents the cumulative frequency or cumulative relative frequency. The horizontal scale consists of the lower limit of the first class followed by the upper limits of all classes. The vertical scale represents the cumulative frequency or relative frequency. The line graph starts on the horizontal axis, the lower limit of the first class, and connects to points representing cumulative frequency or relative frequency of each class located directly above the upper limit of each class. So here is our cumulative frequency distribution. So I draw the vertical horizontal axis, label them. On the horizontal axis you have the lower limit of the first class, then the upper limit of every class after that. Now we put dots on the graph to represent the cumulative frequency for each class, and we connect them with a line segments. And here would be our cumulative frequency ogive. Now if I wanted a cumulative relative frequency ogive, I need cumulative relative frequency. Draw the horizontal vertical axis again using lower limit of the first class, upper limit of each class, and relative frequency, the vertical scale. Locate dots for cumulative relative frequency above each of the upper limits and connect with lines. So there would be your cumulative relative frequency ogive. Now StatCrunch will draw ogives, but again, all you really need is a conceptual understanding for the quizzes. You will need to examine different frequency ogives to see which ogive goes with the given frequency distribution. You will need to look at an ogive and answer questions such as class width, number of classes, frequency less than or equal to a given value, frequency greater than a given value. You will also need to examine different relative frequency ogives to see which ogive goes with the given relative frequency distribution, and be able to answer the same types of questions. Class width, number of classes, cutoff for the lower percent, maybe the lower 10%, lower 20%, and cutoffs for the upper percent, the upper 10%, upper 20%. You'll be able to get this information out of the ogive. Now, drawing a time series plot. A time series plot is obtained by plotting the time in which a variable is measured on the horizontal axis and a corresponding value of the variable on the vertical axis. Line segments are then drawn connecting the points. So if I took the following time series, number of sales in a year, took 2012 through 2018 and recorded the sales. So I'd make my vertical horizontal axis. My horizontal axis would be the years. My vertical axis would be sales. Then I would go ahead and plot the number of sales for each year. So 2012 would go into 25, 2013 would be 38, 2014, 45, etc. So I locate dots above each of those years to record their sales. Then I would come back and connect with line segments. And this would be my time series plot. Now, StatCrunch will draw time series plots, but again, conceptual understanding is all you need for the quizzes. You will need to examine different time series plots to see which plot goes with a given time series distribution. You will be given a time series plot and asked to answer a few questions, such as value at a given point in time with highest value, point in time with lowest value, trend of the time series plot over a given period. This brings us to the end of section 2.3.